Okay, in this video, we're going to be looking at determinants and Cramer's rule. And in this particular video, we're going to look at how to evaluate a second-order determinant, solve a system of linear equations in two variables using Cramer's rule, and also evaluate a third-order determinant. Okay, let's look at a determinant of a 2 by 2 matrix. And we'll define what a determinant is. The determinant is nothing but a real number that is associated with every square matrix. And of course, a square matrix has the same number of rows and the same number of columns. So in this case, a 2 by 2 matrix will have 2 rows, 2 columns. So that will classify as a square matrix. Okay, and this is how we find the determinant of a 2 by 2 matrix. And I'll show you this on the next sheet. Okay, let's say we had this square matrix here. In this case here is written as A1, A2, and then B1, B2. So if you want to evaluate the second order determinant, you're going to find the difference of the product of the two diagonals. So here it's going to be the product of this diagonal from the upper left to lower right minus the product of this diagonal from the lower left to the upper right. So in this case, using letters, it will be A1, B2 minus A2, B1. So again, you're finding the product of this diagonal from the upper left to the lower right minus the product of this diagonal from the lower left to the upper right to evaluate a second order determinant. Okay, now let's look at a couple of examples here. Here I want to evaluate the determinant of each of the following. The first one I have 10, 9, 6, 5, and the second one is 4, 3, negative 5, negative 8. I'm going to show you how to evaluate a second order determinant. Let's use these examples here. So in this case here, the first one was 10, 9, 6, 5. And we usually write this as just the vertical bars in this case. So we have a 10, then 9, 6, and 5. Okay, that's the determinant. That's the matrix that I want to find the determinant for. So here, I find the product of this diagonal going from the upper left to lower right. That's in this case 10 times 5 minus the product of this diagonal from the lower left to the upper right. That's 6 times 9. So if you multiply 10 times 5, that's going to give you 50, minus 6 times 9, that's 54. So 50 minus 54 will give you negative 4. So the determinant of this matrix will be 54. Negative 4, I'm sorry. The determinant here is negative 4. All right, the other matrix was 4, 3, negative 5, negative 8. And I want to find the determinant of this 2 by 2 matrix here. Again, I'll do the same thing that I did in that first example. Take the product of this diagonal from the upper left to lower right. That's 4 times negative 8 minus the product of this diagonal here from the lower left to the upper right. That's negative 5 times 3. So in this case here, if I do 4 times negative 8, that will give me negative 32 minus negative 5 times 3, which will be negative 15. And of course, negative 32 minus a negative 15 is the same as saying negative 32 plus 15, which will be negative 17. So the determinant of that 2 by 2 matrix here would be negative 17. Okay, those are just a couple of examples of how you find a determinant of a 2 by 2 matrix. Okay, now next we're going to apply this particular concept with solving systems of linear systems, linear equations in two variables using determinants. So here, this concept of just finding the determinant of a 2 by 2 matrix here, we're going to apply that to this particular concept. Determinants can be used to solve a linear system in two variables. This method of using determinants to solve a linear system is called Cramers Rule. So in this particular section, in this video, we're going to talk about how to use Cramers Rule and the concept of determinants to solve a system of linear equations in two variables. Okay, so here we're solving a linear system in two variables. Using determinants, we have to have two systems of equations that are in this form. A1x plus B1y is equal to C1. Then A2x plus B2y is equal to C2. And that would mean that x will be this particular method, and that's the setup for it. And I will explain pretty much what each of these determinants are in the numerator and in the denominator on this next sheet. And these are just some helpful tips here. There are three determinants that are used to find x and y. The determinants in the denominators for x and y are identical. The determinants in the numerators for x and y will differ. So in an abbreviated notation, we write this. X is equal to d sub x divided by d, and y is equal to d sub y divided by d. And this is where d is not equal to 0. Okay? So x will be d sub x divided by d, y is equal to d sub y divided by d. Okay? So now, where do we get d sub x, and d sub y from? Let's start off with the elements of d. That's the determinant of the denominator. That will be the coefficients of the variables in the system. So d is always going to be a1 and a2, b1 and b2. a1 and a2 are the coefficients of x, where b1 and b2 are the coefficients of y. Okay? So a1 and a2, the coefficients of x, will go in the first column. b1 and b2 are your coefficients of y. That will go in the second column. That's going to be what d is, which is your determinant of your denominator. All right, now next, we'll talk about where d sub x comes from. That's the determinant in the numerator of x. That's obtained by replacing the x coefficients in d with the constants on the right side of the equation. So in this case, this is what d is. But for d sub x, you replace whatever your coefficients of x are with your constants. So your constants will be in the first column. The coefficients of y will remain in the second column. So you're replacing the coefficients of x with your constants that will go in the first column for d sub x. Okay, now for d sub y, which is going to be the determinant of the numerator for y, you replace your y coefficients with your constants. So this is what d looks like. For d sub y, the a1 and a2, which is your coefficients of x, that will remain in the first column. But in the second column, your y's, which is b1 and b2, those coefficients will be replaced with your constants here. Okay? So here, if you just follow that particular pattern, like for d sub y, we have the x and then your constants. And if you allow me to go back to the other one, for the x, for d sub x, it'll be your constants and your y. D is always going to be x and y, the determinant of your denominator. Okay, now let's look at this to solve this particular system. Here we got 2x minus 3y is equal to negative 11 and x plus 2y is equal to 12. Here we're going to solve this particular system using Cramer's rule. So here we're going to use Cramer's rule to solve this system of linear equations here. Okay, so I'm going to pull up a blank sheet. Now rewrite the equation here. 2x minus 3y is equal to negative 11. And the other equation is x plus 2y is equal to 12. So here we want to solve this system of equations using Cramer's rule. Okay, there are three determinants that you're going to need. You're going to need a determinant for d, which is your denominator, a determinant for x, that's always your numerator, and your other numerator is your determinant for y. So here we're going to have three different determinants that we're going to have to set up and then find out what each of those determinants are. D is always going to be the coefficients of x and y. So if you want to, you can write x and y up here to help you be reminded that for D, your coefficients, you're going to put x and y as your coefficients in those columns. Let's look at this here. Okay, but the x's is going to be a 2 and a 1, and we have to put those numbers in that particular order. So the 2 goes on top and the 1 goes on the bottom. For y, negative 3 and 2. That goes here. Okay, now for the determinant for x. Now your x is going to be replaced with your constants, and then your y's will go in this column. So instead of putting your x coefficients in this column, you're going to put the constants here. Your constants here are negative 11 and 12. So we'll put negative 11 here and 12 here. Your y's are still going to be negative 3 and 2. Those are still your coefficients for y's that still go here. Now for the determinant of y, here the first column will be your x coefficients. The second column, instead of your y's coefficients, you're going to put the constants there in its place. So the coefficients of x, again, that's 2, 1. And then for the constants, that's negative 11 and 12. Okay? Now we're going to have to find the determinants for each one of these three matrices. D of x, and d sub y. Let's start off with the d. If you recall, we always subtract the diagonals from the upper left to the lower right, minus the product of the diagonals from the lower left to upper right. Here, 2 times 2, that's 4. Minus 1 times negative 3 will be negative 3. So now 4 minus a negative 3 would be positive 7. So our d here is positive 7. Okay, now for d sub x, that's done the same way. Negative 11 times 2 is negative 22. Minus 12 times negative 3 is negative 36. So now negative 22 minus negative 36 would be 14. Okay, so d sub x will be positive 14. Now d sub y, we do this diagonal. 12 times 2, that's 24. Minus 1 times negative 11 will be negative 11. Now 24 minus negative 11 will be positive 35. So d sub y will be positive 35. Okay? So now we have our determinants for d sub x, and d sub y. We can evaluate x and y. And if you recall, x is always d sub x divided by d. And d sub x was 14 divided by your d, which is 7. So 14 divided by 7, that's 2. And then for y, that's d sub y divided by d. In this case, d sub y was 35. D sub x is 7. 35 divided by 7 is 5. So we found out what x and y are going to be. 2, 5. So the ordered pair for this system of linear equations is going to be 2, 5. Okay, so this is how we apply Cramer's rule to solve a system of linear equations in two variables. Okay, all right, let's look at another example here. Here I want to solve this system using Cramer's rule as well. 5x plus 4y is equal to 12, and 3x plus 6y is equal to 24. Okay, so in this case here, we can go ahead and do that one. Okay, so in this case here, we got 5x plus 4y is equal to 12. And 3x plus 6y is equal to 24. That's my system of equations that I want to find out what x and y is using Cramer's rule. Okay, we need to find out what d is. We need to find out what d sub x is. And we need to find out what d sub y is. Okay, d is always the coefficients of x and y. So for x, it's going to be, in this case, 5 and 3. So we put the 5 and the 3 in this first column in that order. And for y, the coefficients are 4 and 6. So the 4 and the 6 goes in that column, in that particular order. Now d sub x, instead of the x going in the first column, we put our constants, and then our y's go in the second column. Our constants are 12 and 24. So the 12 goes here, 24 goes here. For the y, we bring over the 4 and the 6. And then for d sub y, we have the x, but our y coefficients will be replaced by the constants. The coefficients of x are 5 and 3. And the coefficients of y, the constants are 12 and 24. We replace the coefficients of y with our constants. Now we want to find the determinants of d sub x, and d sub y. In this case here, for d, we're going to do 30 from 5 times 6 minus 3 times 4, that's 12. So 30 minus 12, that's simply 18. So d is equal to 18. That's the determinant of your denominator. Now for the determinant of x, we're going to do, in this case, 12 times 6, that's 72. Minus 24 times 4, that's 96. So 72 minus 96 will be a negative 24. And then d sub y is this. 5 times 24 is 120. Minus 3 times 12, that's 36. So 120 minus 36 will give me 84. So d sub y is 84. Okay, we have d sub x, d sub y. Now we need to find out what x and y is, or what x and y are. X is d sub x divided by d. D sub x is negative 24 divided by d, which is 18. So negative 24 over 18. If you reduce that in simplest form, we'll leave that as an improper fraction of a negative 4/3. So x is equal to negative 4/3. Now for the y, that's d sub y divided by d. That would be 84, because that's what d sub y is, 84 divided by d, which is 18. So 84/18, reduce that as an improper fraction in simplest form, will be 14/3. So your y is 14/3. So the ordered pair for this system of linear equations will be -4/3, 14/3. Okay, so this is an example of how we solve a system of equations using Cramer's rule. Okay. All right. Now the next thing we'll talk about is a couple of special cases where you might have inconsistent and dependent systems. Okay. Now what this says here is this: if your d, which is your determinant of your denominator, is 0, and at least one of the determinants in the numerator is not 0, then that system is inconsistent, meaning that your solution set will be the empty set. Okay? That's basically what this first one says. And then the second one, if d is equal to 0 and all the determinants in the numerators are 0, then the equations in the systems are dependent. Then that means that system has infinitely many solutions. Okay, so if your d is 0, but the determinants of x and y are not 0, then you have an inconsistent system of equations, meaning you have an empty set as your solution set. But if d sub x, and d sub y are all zeros, then that means that the system is dependent, meaning we have infinitely many solutions. So here's one example of that. Let's say we want to use Cramer's rule to solve this system. We got 3x plus 3y is equal to 2, and 2x plus 2y is equal to 3. Okay, so let's look at this one. Three x plus 3y is equal to 2. 2x plus 2y is equal to 3. That's our system of equations that we want to solve using Cramer's rule. So in this case here, let's find out what d is, or set up what d is, which is your x and your y. And for your x's, that's 3 and 2. For your y column, that's also 3 and 2. Now d sub x, we replace the first column with the constants, which is in this case 2 and 3. And the second column is your coefficients of y's, which is 3, 2. And then d sub y, your first column is your x's, that's 3 and 2. But for y, we replace that, well, the second column is going to be replacing the y coefficients with your constants 2 and 3. Okay. Now we're going to find the determinants of d sub x, and d sub y, as we did before. Now for d, this first one, your determinant of your denominator, 3 times 2 is 6, minus 2 times 3, that's 6. 6 minus 6 is equal to 0. Now what about d sub x? 2 times 2, that's 4. Minus 3 times 3 is 9. 4 minus 9, that's negative 5. So d sub x is negative 5 for that determinant. Now the determinant for d sub y is this. 3 times 3 is 9. Minus 2 times 2, that's 4. 9 minus 4 is 5. Now as you can see, the determinant is 0, but d sub x and d sub y are not 0. Okay? And even if you try to find out what x is, or if you try to find out what y is, notice d is 0. So for d sub x, that's going to be like negative 5 over 0. And we know we can't divide by 0. That's undefined. And the same holds true if we try to find out what y is, which is, of course, d sub y divided by d. Again, and in this case, that's 5 over 0 as well. Again, you have a 0 in the denominator. So we can conclude that this system is inconsistent. So we have an inconsistent system of linear equations. So the solution set will simply be the empty set. Okay. All right, another example would be this. Let's say we had x plus 2y is equal to 3 and 4x plus 8y is equal to 12. And here we want to solve this system of equations using Cramer's rule as well. Okay, so here's what we're going to do. Okay, now write the equation as is. X plus 2y is equal to 3. 4x plus 8y is equal to 12. And here we want to solve the system of equations using Cramer's rule. We need d, and that's going to come from the coefficients of x and the y. So it'll be 1, 4, 2, 8. Now for d sub x, that's d sub x there. Your x column will be replaced by your constants, which is now 3, 12. This column is your coefficient of y, 2, 8. Then for d sub y, the x column is 1, 4. Now the y column is replaced with your constants 3, 12. Okay, so now we're going to find the determinant, the d of d sub x and d sub y. So in this case here, for d, if we do 1 times 8, that's 8, minus 4 times 2, that's 8. 8 minus 8 is 0. Now for the determinant of x, 3 times 8, that's 24, minus 12 times 2 is 24. 24 minus 24 is 0. Then for d sub y, 1 times 2 is 12, 4 times 3 is 12, 12 minus 12 is 0. Notice that the determinants for d sub x, and d sub y are all zeros here. So in this case here, we have what we call a dependent system of equations. And the solution set would be, we'll just say that this system of equation has infinitely many solutions, because the determinant of d sub x, and d sub y are all zeros. Okay, so far we looked at a 2 by 2 matrix. Now let's look at a 3 by 3 matrix and how to find its determinant. Okay, associated with every square matrix is a real number called its determinant. The determinant of a 3 by 3 matrix is defined as follows. And I do have a better illustration of what this says here. So if you give me a minute to pull this up, because it does clearly state what this means. And the way I did this was I took the matrix A1, A2, A3, B1, B2, B3, C1, C2, and C3. Here's what I did. I rewrote the first 2 columns of this matrix. So A1, A2, and A3 are rewritten here. B1, B2, and B3 are also rewritten. And what I did was I took the product of the first 3 diagonals coming the sum of the products of the first three diagonals coming this way from the upper left to the lower right. And then I minus each of the products of the diagonals going this way from the lower left to the upper right. So this was going to be A1, A2, A1, B2, C3. That's this product plus this, the product of this diagonal, B1, C2, A3, plus the product of this diagonal, C1, A2, B3. And then I minus the product of these diagonals. I minus each of the product of those diagonals coming from the lower left to the upper right. So I have A3, B2, C1, which is this product, minus B3, C2, A1, that's this product, and then minus C3, A2, B1, that's this product right here. Okay. In fact, later on I'm going to show you that's the easy. I'm going to use this to show you the easy way to find that determinant of that 3x3 matrix, because that's what they use here to define the determinant of a third order, or to find the third order determinant. Okay, now here we're going to look at expansion by minors here, because this is also a definition of a determinant of a 3x3 matrix. Okay, and I will be explaining what each one of these means. This is what we call expansion by minors. The first part is a plus, and then the second part you subtract, the third part you add. So you just alternate plus and minuses in this case here. Now, let's look at this next one. It says that each of the three terms in the definition contains two factors, a numerical factor and a second order determinant. The numerical factor in each term is an element from the first column of the third order determinant. The minus sign precedes the second term. The second order determinant that appears in each term is obtained by crossing out the row and the column containing the numerical factor. So in this case here, if we use A1, from here we cross out the column and the row that A1 is in. What's left is going to be that determinant, that second order determinant. In this case, B2, B3, C2, C3. And similarly, if we do A2, we cross out the row and the column that A2 is in. In this case, A2 is in the second row, first column. What's left is B1, C1, B3, C3. And for A3, A3 is in the third row, first column, so we cross out the column and the row that A3 is in. What's left is B1, C2, B2, C3, B1, C1, then B2, C2. Okay, and we call this expansion by minors. Okay, that's what that is. And we do have a study tip. Okay, so when you expand a determinant by minors about any row or column, you want to use alternating plus and minus signs here. So here, the first row, first column is a plus, then a minus, then a plus, then minus, plus, minus, plus, minus, plus. So you're alternating plus and minus signs here. Okay. Now let's look at this. We're going to use this to expand by minors here. Okay, let's say we had this matrix here. 2, 1, 7, negative 5, 6, 0, negative 4, 3, 1. And we want to evaluate the determinant of that following matrix. So here, okay, let's do this by expansion by minors. And then I'm going to show you the way that how I would do this. Okay, the first thing I'm going to do here is use the first column of this given matrix here. So I'm going to use this first column right here, 2, -5, 4. Those numbers would go on the outside of the 2 by 2 matrix. Okay, so in this case here, if the 2 goes here, if I eliminate the first row, now the 2 is in the first row, first column, as you can see here, which means if I eliminate the row that the 2 is in and the column that the 2 is in, eliminate the first row and the first column, this is what I'm going to have as my 2 by 2 matrix. 6, 0, 3, 1. Okay. And I'll show you again. The 2 is in the first row, first column. Eliminate that. That's what you'll have as your minor. 6, 0, 3, 1. Okay. Now, the first term is a plus. The second term is going to be minus. Now, the second term is in that column is -5. So let's use a -5. Now, -5 is in the second row, first column. So eliminate the first column. Eliminate the second row that the -5 is in. As you can see, the remaining numbers make up makes up that 2 by 2 matrix, which is 1, 7, 3, 1. So that's going to go here. And then if this is plus, this is minus, this will have to be plus. And then the -4, that goes on the outside of my 2 by 2 matrix. -4 is in the third row, first column. So eliminate the first column, eliminate the third row. Look what you got, 1760. That goes here. Okay. Now here's what we're going to do here. We're going to find the determinant, and then we're going to multiply that determinant by the number that's on the outside. Okay, so we bring down the 2. Now we're going to do 6 times 1, that's going to be 6, minus 3 times 0, that's 0. Now, minus the -5, we can change that to a +5, and then get its determinant. 1 times 1 is 1, minus 3 times 7 is 21. Then, plus, okay, we'll say -4, and then get its determinant. 1 times 0 is 0, minus 6 times 7, that's 42. And then we're going to simplify this a bit. 6 minus 0 is 6, so that's 2 times 6, plus 5 times 1 minus 21 is -20, plus -4 times 0 minus 42 is -42. Okay, and then 2 times 6, that will give me 12. 5 times -20, that's going to be -100, so I have 12 minus 100. Minus -4 times the -42 will be a positive 168. So that's plus 168. Now, if you do -12 plus 100, that's -88. -88 plus 168 will give you 80. So the determinant of that 3 by 3 matrix using expansion by minors would be 80. Now I realize that that can be quite a little bit time consuming here, but I'm going to show you how I would do it using this approach that I mentioned not too long ago. And this is going to be quite easy. Okay, let's say, and I'll rewrite that particular matrix that I had earlier. So here, this is 2, -5, -4, 1, 6, 3, 7, 0, 1. That's my matrix I had earlier. Now another way that we can do it is this. Rewrite the first two columns of this matrix. So this will be 2, -5, -4, and then 1, 6, 3. Now here's how we're going to find the determinant. We're going to find the product of these diagonals going from the sum of each product of each diagonal going from the upper left to lower right. So now you got 2 times 6 times 1. That's going to give you 12. This diagonal, 1 times 0 is 0, times -4 is 0. So that's 12 plus 0, plus 7 times -5 is -35. -35 plus 3 is -105. And then we're going to minus each of these diagonals going from the lower left to upper right. Okay. So we just minus each product of each diagonal going from the lower left to upper right. So in this case here, -4 times 6 is -24. -24 times 7 was -168. Minus 3 times 0 is 0, times 2 is 0. That was easy. Minus 1 times -5 is -5 times 1, which is -5. Now, you can use your calculator and add those numbers together. So if you were to add 12 plus 0 plus -105 minus a -168 minus 0 minus -5, you would get 80, which is exactly what we came up with when we did expansion by minor. So the determinant of that 3 by 3 matrix used in this particular procedure would be 80. Okay. And I also can show you how to do this using the calculator if you would like to know how that's done. Okay, so here's the calculator here. Now the way we do that, we're going to put it in the form of a matrix. So here we're going to press second and X to the 1 to pull up the matrix menu. We're putting in a new matrix here. So use your right arrow key to highlight edit. And we're going to select number 1 because we're going to store this one in matrix A. Now in this case, let me get the original matrix that I started off with. Okay, in this case, as you can see, this is a 3-row, 3-column matrix. It's a square matrix, by the way. So in this case here, the first number is the number of rows. The second number is the number of columns. 3 rows, 3 columns. So we press enter 3, then enter, then 3, enter, because we want a square matrix. 3 rows, 3 columns. Then we enter each element row by row. So in this case here, 217, we enter the 2, then enter 1, enter 7, enter. Second row, -5, enter, 6, enter, 0, enter. And then the third row, -4, enter, then 3, enter, and then 1, enter. And then to exit out of this, we hit second and then mode to quit. Okay, now we're going to press second and then exit the -1. But this time we want to select the menu that says math. So we use the right arrow key. Now notice in number 1 you're going to see DET. That's the abbreviation for determinant. So here we're going to find the determinant of this 3 by 3 matrix. So we're going to select number 1 for the determinant. Now we stored that matrix in A, so we're going to hit second matrix and then number 1 and then hit enter. Close your parentheses, then hit enter. As you can see, that determinant is, in this case here, 80. So the determinant of that 3 by 3 matrix that we just did was 80, which is exactly what we came up with. Okay, so here, those are just some ways of using a calculator to find the determinant of any 3 by 3 matrix. Okay, and that will conclude this particular section on matrices, determinants and Cramer's rule.